June 2019, question number 4A says, the quantity P varies inversely as the square of V. The quantity P varies inversely as the square of V. Using the letters P, V, and K form an equation connecting the quantities P, and V. Alright, so this is a question on variation, and we're told that the quantity P varies inversely as the square of V. So in other words, P is equal to K divided by V squared. Here, where K is the constant of variation, the word used is inversely. If the word used is inversely, the variation equation is going to be P is equal to K divided by. If the word used was directly, it would have been P is equal to K multiplied by. All right, so that's the first thing. Next, we're told, given that V is equal to what? V is equal to 3 and P is equal to 4, determine the positive value of V when P is 1. Alright, so V is 3 when P is 4. So I can use that information to determine what is the value of K. So when V is what? When V is 3, P is 4. So I can have 4 is equal to K divided by V square, which is what? 3 square. So now I have 4 is equal to K over 9. I'm going to put my 4 over 1. If I have one fraction is equal to one fraction, I can cross multiply. So 1 times K is K, and 4 times 9 is 36. So K is equal to 36. So now that I know what is the value of K, I can rewrite the equation. The equation is actually P is equal to 36, which is K, divided by V squared. Alright, so next now I can use this information to determine the value of P when V is 1. So I'm going to say when V is 1, the value of P, the value of V when P is 1. So it's when P is equal to 1, I'm going to have 1 is equal to 36 over V squared. If I have one fraction is equal to one fraction, I should cross multiply. So therefore I'm going to have V squared is equal to 36. The opposite of square is square root, so V is equal to the square root of 36. V is equal to 6. Alright, so this question is a question on variation. Alright, next we have a question on inequality. We have an inequality question, and the question says, it says, given that x is a real number, solve the inequality. Alright, so this is actually two inequalities in one. We have minus 7 is less than 3x plus 5, and over here is which is less than or equal to 7. So this is actually two inequalities in one, and this inequality is read from in the middle. If I want, I could take them apart and solve them individually, or I could just solve it. If you're knowledgeable enough, you could just solve it as one inequality. So the first thing I'm going to do when I'm finished, all I should have in the middle is x. First thing I'm going to do is 3x is less than or equal to 7 minus 5. So positive 5 goes over and become negative, and I do the same thing over the other side. Over there I have what, so this is going to be what, minus 7 minus 5. Alright, so positive 5 goes over and become negative. So now I have 3x is less than or equal to 2 but greater than minus 12. So the next thing I'm going to do is divide the entire inequality by 3. So now I have x is less than or equal to 2 over 3 but greater than minus 4. Alright, so I just solved the inequality. Alright, next now, what am I asked to do next? So next now we're asked to represent your answer from BI on the number line shown below. Alright, so let's put some more information on our number line. 1, 2, 3 over here, minus 1, minus 2, minus 3, minus 4, minus 5. Alright, so x is less than or equal to 2 over 3. 2 over 3 is 2/3, which is less than 1. So let us say my 2/3 is here. Alright, I'm going to shade the circle, indicating that x is equal to 2/3 is a possible solution, because x is less than or equal to 2/3, meaning that x could be 2/3. Over here at 4, I'm going to leave that circle blank, indicating because x is greater than minus 4, indicating that x is greater than 4, it cannot be 4. So x is equal to 4 is not a part of the solution. So in this region here is the region where x is what? Less than 2/3, less than or equal to 2/3, but greater than minus 4. So this is x is less than or equal to 2 over 3, but greater than minus 4. Alright, next. So next we're told that, so this looks like coordinate geometry. The equation of a straight line is given as x over 3 plus y over 7 is equal to 1. This line crosses the y-axis at Q. We're to determine the coordinates of Q. So the first thing here is to remember that the y-axis is the line x is equal to 0. So I already have my x-coordinate. The x-coordinate is x is equal to 0. Alright, or all points on the y-axis, because the y-axis is the line x is equal to 0, the x-coordinate of all points on the y-axis is 0. So I'm going to put x is equal to 0 in my equation. I'm going to say when x is equal to 0, I have 0 over 3 plus y over 7 is equal to 1. This goes, so over here, cross multiply, I have 1 times y is y. So that's y is equal to 7 times 1, which is 7. So x is 0 and y is 7. I would say that Q is the point 0, 7. Q is the point 0, 7. Alright, next. So the next thing and the last thing in the question is we're to determine what is the gradient of the line. So we have x over 3 plus y over 7 is equal to 1. We have x over 3 plus y over 7 is equal to 1. Now, if we can get it in this form, y is equal to mx plus c, we can easily say what the gradient is. So let's get rid of the fractions. I'm going to find the LCM, use the LCM, and then discard the LCM. The LCM is 21. 3 into 21 is 7. 7 times x is 7x. 7 to 21 is 3. 3 times y is 3y. Is equal to 1 into 21 is 21. 21 times 1 is 21. So I found the LCM. I use the LCM. Next, I'm going to discard the LCM. So now I have 7x plus 3y is equal to 21. I need to have y on the left hand side by itself. So now I can say 3y is equal to minus 7x plus 21. Positive 7x goes over and become negative. And the last step in my effort to get it in the form y is equal to mx plus c is to divide the entire equation by 3. So now I have y is equal to minus 7 over 3x plus 7. Alright, now once it's in this form, the coefficient of x, m, the gradient, is equal to minus 7 over 3. So the gradient is equal to minus 7 over 3.